Hey guys, we're about to start in 2 minutes. But I want to thank Oren for being here today. We're gonna stream on YouTube and we will be live on Zoom. Please use the Slido with the NoSQL event code to be able to add questions. We're gonna address questions at the end, so we're gonna run smooth. And ready when Oren is?
I'm ready.
Okay, so let's get this started.
Okay, thank you. So this talk is about modeling in non-relational world. And it's interesting because I'm going to talk about modeling mostly in a negative sense. And this is because for most of us, there is a one true way that we were taught how to model. Data is modeled using relations, table, foreign keys, constraints, those sort of things. And that's the way it's supposed to be. If you look at the industry at large, this has been a hugely entrenched thinking to the point where people don't even realize that they have this situation. It just is. And because of that, that leads to some interesting issues. And let's talk about a couple of them very quickly. What we see here, this is a paycheck. This is a check for John Doe for some amount of money from Google. Now, here you can see that there are two. Hello? Okay. Here you can see that there are two ways that I can model that the data. On the top row, I have storing the data as is, just as it appears on the paycheck. On the bottom, I'm storing. I'm not sure what happened, but there is someone screaming.
Yeah, apparently
Yeah,
we're gonna
I
kick
really
that
hope.
person out. Oh
Okay.
my god.
Yeah, it
Okay.
sounds very much like someone was murdered.
Yeah.
Hopefully, that's not the case. Uh, anyway, so there are two ways of representing this data. And the top one is denormalized and the bottom one is normalized. Now, if you look at conventional wisdom, how should a model this data? A lot of people would immediately point to the first option, to the second option, to the normalized model, because they have been told that, oh, this is the way it should be. Data should be normalized. Otherwise, you risk data duplication of data. Otherwise, you risk modifying some data but not other. But this is actually a really interesting case study because what you see here is a chance for data corruption. What do I mean by that? Once I issue this check, it is done. There are no modification that can happen on this check. If user 23 change their name, the name of this check does not change. I actually want and need to have copy of the data of whatever the username was at the time of the issue of this check, because this represents a value as a point in time. And that tends to be something that is quite hard to realize in many cases. Because in a relational database, the first thing that we do is, oh, let's create foreign keys. Let's use references. Let's save in space. Now, when we do that, we risk having data corruption. Because if user 23 is changing their name, the data that I have in my database about this check is no longer correct. So we have to understand the difference between point in time, between two values that are the same but not necessarily mean the same thing. This value here, this is the username, but it is not equal to the name of the user. This is the username at the time the check was issued. That is the first thing that we need to understand. The second thing we need to understand is why are we pushed? Why was normalization pushed so hard? Why is it so important? And the answer is this. What you can see right here are two hard disks. The one on the right, this one, is a 5 megabyte hard disk from 1956. It weighs about a ton, a metric ton for 5 megabyte. This guy is from the late 70s, and this is much better. This is 2.6 gigabyte. Notice how this guy is dressed. This is a clean room. If you want to go near this really expensive machine, you dress appropriately. Just to give you some ideas about the numbers, this thing was not sold. No one would buy something like this. It was too expensive. Instead, you rent it out. And you rent it out at an amount of $3,200 per month. Now, $3,200 per month doesn't sound like much, at least not today. But remember, those are in 1956 dollars. In other words, we have to account for about 70 years of inflation. Now, just to give you some ideas, I went into the Bureau of Statistics and looked things up. In 1956, the average salary for a man was $3,600. In other words, you paid on a monthly basis almost as much as you would pay on a year for an employee. Translating into today's dollar, this is upward of $30,000 per month. This is a hugely expensive thing. This is for 5 megabyte. This thing also costs tens of thousands. At this point, you could actually buy it, but really expensive. And those were the kind of things that he used to store data. And when the cost per byte is measured in many dollars, you really, really care. So people were willing to go to a lot of trouble in order to reduce the amount of disk space they were using. Now, today, it is literally not worth your time to go into S3 and delete data that you have there lying around. It's cheaper not to do anything, which is somewhat sad, but that's the case. But we have to understand that relational databases and a lot of the design thinking around them has evolved around that time frame, where this space was a premium. And that mattered because people were willing to go into a lot more trouble in order to reduce this space than we're willing to do today. And the absolute worst thing about relational database from my perspective is this. I will give you a moment to behold this schema. And I want you to look at something really interesting. Look at the number of columns in each one of these tables. Those are relatively small tables. If I want to make sense out of this thing, I have to gather information from many locations. I have to join tables. Now, if you're familiar with how databases actually work, when I need to join two tables, it means that I have to fetch data from two separate locations. Now, try to imagine how often are you actually needing to join only two tables? In many cases, you need to join a lot more, and you need to do a lot more work, which is really expensive. Now, computers have become fast enough that for the most part, we aren't really feeling that. We haven't seen all of the cost of working with normalized data sets that require us to fetch all of the data. Until we get to the point where we actually need to show an overall view. I'm not going to go into an overly complex system. Let's talk about orders page. You have orders, an order contain multiple line items, there are products that you purchase, there are payments, there are discounts, offer that were applied. When you go to the supermarket and you get this long receipt and it has all of the things that you purchase and a whole bunch of other stuff like that, try to imagine how you would model something like that in a relational database. And now go the other way around and try to imagine how am I actually going to fetch all of the data? What is the query that I'm going to run? And then you realize that given the number of tables that you have and the overall complexity of the model, the database is going to work really, really hard in order to handle that. About almost 20 years now, dear God, this book came out. It's called DomainDriven Design. It's a really good book. It's very dry, but the concept there was that we need to move from thinking about the data in terms of tables, in terms of individual data items that we operate on. Instead, we want to start thinking about the data as with the concept of aggregate routes. Now, what is an aggregate route? An aggregate route is something that contain everything about a specific business context. And if you go back to the notion of an order is composed of many different tables. Orders, order lines, products, payments, discounts, all of that. But the aggregate route is the order. And the idea here is that the aggregate route is the location to which you have the scope of your business rules. For example, I may have a business rules that say, if I add an item to the cart, to the order, and that item already exists, I'm not going to have two line items for 1 second. Sorry, I'm not going to have two line items for the same product. I'm going to increase the quantity. So that's a good rule. And at the same time, if I'm doing that on two separate orders, it doesn't matter. Because my scope for doing those sort of things is the single order that I'm using. So I'm probably not doing too good of a job of explaining that. There is a lot of material on domain-driven design online that I urge you to go through. But the key here was that people started to shift their thinking from tabular model to the aggregate model. Instead of thinking about all of my objects as they lay around in isolated tables, I'm going to say, okay, let's bring them all together and think about them as a single location. And as it turns out, this is very much how many business people are thinking about the data. And they think about the data because they think about data in terms of documents. Now, what is a document? A document is some piece of data that we store and allows me to look into the entire thing in one location, in one place. Let me give you an example. What you see here is RevenDB, and here is a relatively simple document. This is just JSON. I don't believe that anyone here is going to be surprised by this. JSON, document, that's about it. It gets interesting when we start talking about more complex data. For example, here is an order. And now we can see that I have line items. And now the line items, instead of being in a separate table, instead of requiring me to do a join, I'm able to fetch the data as it comes directly, easily and without issues. That makes things a lot simpler for me. The other thing that matters here is that now all of the operations on this particular order are going to be serialized, are going to be, and that's important because that allows me to have business rules within the appropriate scope. So the whole idea is that the document is my aggregate, and a document is how I'm modeling the data. It turns out that this is very nice for business people because you can tell them, okay, here is the web page. This is what you see on the screen. This is how the data is actually modeled in the backend. So a lot of the things that suddenly become very hard to explain, oh, why is it hard to find how many this particular piece of data? Well, because I have to crawl through 16 different tables to find it. But if you show them, okay, here is page 1, here's page 2, here's page 3, now you can explain to them visually and succinctly how the data is actually stored. Now, that leads to a very interesting problem because, okay, I move from storing data in I moved from storing the data in tables to storing the data in documents, JSON documents. Okay, am I done? This is it? Okay, let's move for questions. That's it. But as it turns out, there's actually quite a lot of important rules that we have to consider when we model data in a non-relational form. This is why I have this talk. So the first thing that we need to understand is that probably the biggest stumbling block when you come to work with something like a document database, and we have RavenDB here, there is Mongo, CouchDB, CosmosDB, there is a plethora of databases that have moved from the strict relation model into a document model. Almost all of them use a JSON. There are a few, such as MarkLogic, that use XML. But the important bit about here is that all of them allow you to model roughly in the same manner. And let's talk about what this actually means. What this actually means is that, okay, I have the ability to model arbitrary complex data quite easily in here. Now, what are the rules? Well, with RavenDB, what I'm using here, there are very few rules. I can decide that, you know what? Each document is going to have its own set of fields. I can decide that, oh, you know what? Let's put an entire product catalog inside a single document. I can do a lot of stuff that is maybe possible, but not necessarily interesting or good for us. So let's talk about some modern rules for documents. And again, the core of this is based on domain-driven design, on the idea that we have aggregates and values. Now, go back to the idea, to the concept of a paycheck. A paycheck is a document. And you can see here are all of the fields that I need to store. Who do I pay this to? Some details about it, how much, in what currency, who authorized that, some numbers that only make sense for the bank, when it was issued, who it was issued to. Now, so far this is good. Now, here's a question. What was this checked issue for? So there's probably going to be an invoice here. And now I have to make a decision in terms of modeling. Am I going to store the invoice ID or the invoice data on this paycheck? And it turns out that in many cases, the physical world is a really good guide for us. Go and look at the actual documents, and they will tell you why it matters. So the first thing that we need to make sure when we talk about document modeling is that the document is coherent. Now, what does it mean? It means that a document should be legible on its own. You don't have to go and fetch additional data in order to make sense of a document. If I'm looking at a check, I know everything I need to know about this check. I may not know what it was paid for. By the way, that might be by design. That's why we have the stub, and that's the man with the person who issued the check. But the whole idea is that I'm able to look at this check and know, okay, I can go to the bank, they will issue that they will give John Doe some money, which is great. The other thing that is important is that a document should be isolated. What does it mean that a document should be isolated? It means that when I'm going to have to change a document, I don't have to change other documents as well in order for it to make sense. And the easiest way for me to explain that is in the negative. Let's say that I don't have this. Let's say that I have this line counts and I have something like this. Now, whenever I need to modify this to add a new item to the order, I'm also going to have to go to the order itself and modify the line numbers that I have there. And that was 289. I have to go and modify this. So in this case, we're going to say that the documents are not isolated. Modifying one document requires us to modify a different document. Now, that leads to a whole different question. What about transactions? Now, relational database has transaction. That's one of the core strengths. That's really important. But non-relational databases, some have them and some don't. RavenDB, for example, is a transactional database. It is perfectly possible for you to modify two documents in the same transactions, and they're going to be saved durably and atomically and all of that. Other database, not necessarily. For example, Mongo by default would run separate transaction for each document modification. Does this matter? If I'm going to say that my data is isolated, what does it matter that I have transactions? Let's go back to the notion of the paycheck, of paying someone. When I'm paying someone, and this is the classical example for transactions, I want to be able to deduct money from one account and show up on another account. It is fine if the operation failed in one of two ways. No money was moved, or the money was actually moved. It is not fine if money appear or disappear out of thin air. So in this case, I may have two independent bank accounts, and I want to remove $5 from here and add $5 from here and do it in a transaction. Does it mean that they're not isolated? No, it does not mean that. They're still isolated. You can still make changes to each individual bank account independently. For example, if I need to compute how many fees I have to charge a particular account, I can do that using just this particular account. I don't have to deal with other accounts that may have been related. So that's a very important aspect. It means that I'm freed from having to manage complex state. I have to generally look only on a single document to work with this. The other thing that we have to deal with is that we should talk about documents being independent. Concise here is supposed to be independent, I'm sorry. So what does it mean independent? It means that this document has a right to exist. It means that, going back to this guy does not have a right to exist. No one is ever interested in this guy. We're only interested in it in the context of the order. This should be, so it bugs me. So in the context of this, it makes sense. So this is not an independent document. And again, this actually turns out to be a crucial matter. Let's say that what I have to deal with is the orders example, and I need to apply some transformation. I just apply a coupon. something like this. And now I have to apply this to everything. It is much, much simpler to just apply it to everything when we have a single object. By the way, it also matches very closely how you would deal with the data in terms of your object model. If we look at this here, here is the order as a C# class. It has a list of order lines, which is also a C# class. And when I'm loading this order, I'm loading the whole thing as a single unit. I'm making modification, I can run on that, change that, and make the modification all at once. It become much simpler for me to handle at this point. Now, there are issues. The most important one of them is that size matters. Quite a lot in some cases. Now, what do I mean by that? The downside of saying, oh, let's put all of your data in the context of a single aggregate root is that you may end up with a document that is really, really large. Really large, I'm talking about megabytes. Now, in the context of RavenDB, a document can reach, I think, 2 GB in size before you have any issues. Mongo is 16 megabyte, I think, and other database has similar limitation. But even if we had no such limitations, let's just increase the size of this to make a point. You can track how big this is here. And at this point, you can see that this is relatively frozen because what's going on right now is that I'm starting to have trouble with the user interface. The actual database has no issue with storing or working with the data, but the problem here is that we have an issue here with the working with that much data, parsing that, displaying that, all sorts of stuff like that. So we have to think about, okay, how do I deal with something like that? In the case of an order, and in a B2B scenario, it's very likely that we may have an order that is composed of millions of line items. At that point, you have to take a step back and consider, wait a second, how am I actually modeling that using paperwork? Would people actually expect to submit 200 pages of here all of the line item, here all of the things that I want in this order? Or are these more in the sense that, okay, I'm ordering for an entire factory for a period of 6 months, and each department say, here are the things that we need. So this is actually something that is composed of many smaller requisitions, let's call it this way. Another good example of data that may be unbounded is in the context of bank accounts. Let's look at that. So here I have something like this. Now, this is try to mention that this is how I would model my bank account with just a little list of transactions order by date. And that makes sense. This is how, in most cases, we look at our bank account. But bank accounts are really long-lived objects. My first bank account was opened at age 15 or 16, I think, and I still have it, which means, unfortunately, that I have more than 20 years of history with that. And quite a few transactions. Now, let's think about the concept of storing all of the transactions inside a single document. What would the implications of that? The implication of that would be that the more successful you are, the more transaction you have, so the more money you make for the bank in fees, the slower you become, because each and every time I have to load this increasingly big array, operate on that and save it back. That's horrendously expensive. I don't want to do that. What can I do? Well, as it turns out, banks don't think about your bank account as an uninterrupted list of transactions. Instead, they're thinking about that as a list of transactions on a per month or per a day. And this is related to the, oh, sorry. This is related to the fact that the billing structure is tied to, oh, if I have, let's say I'm starting with $145 in my account, and add 5, remove 155. Now in the negative, and now I'm supposed to be 0. If I'm thinking about the data from this concept, it makes it very hard for me to do things such as the notion of a business day. It's making it very hard for me to do things such as how do I deal with, oh, you had this much money in your account for this month, therefore this is how much I should pay you in interest or charge you interest, those sort of things. The typical way I would model such things is something like this. In other words, I'm going to have a document per month per count. Or if this is a business account, it's likely to have quite a few transactions. I'm going to go and drill down into the day level. And so at that point, the concept is simple. Logically speaking, I still have one big document. But practically speaking, I don't think I care how much money I had in my account in August of 2009. Do you? I mean, maybe there is some scenario which require me to understand that. In divorce, in frauds, there are certain cases where I want to be able to look at money from long ago. But on a day-to-day business, the tip of the transaction history is what matters, and this gives me a very nice way to handle that. It also allows me to significantly reduce the overall cost that I have on my system. Okay. We talked about the normalization a little bit when we talk about paychecks. So let's talk about what it means in terms of what sort of issue does it cause. By the way, notice that this is broken. This is broken intentionally. The normalization has two issues. The first of which is that we have to deal with identifying point-in-time values. And point-in-time values are stuff like this and this. At the time that I added the product 2A to my account, to my order, it cost 19 and it was called chunk. Though this is duplicated data. This is intentionally duplicated because this value here is not a product name. This is actually the product name at the time I added that to the order. Same thing here. Now, so that's one sort of normalization that tends to bite me, and I've seen many people make mistakes around that issue. At the same time, that leads to issues like, oh, why did you pay 50 for this order? You should have paid 60. Oh, because at the time that I added this to the product, to the order, it cost less, stuff like that. The other issue that it causes is the cost of actually getting all of the data. Consider this case. Everything I need to show for this order is right here. It's located right in front of me. I don't need to do anything in order to show the order page beyond just loading a single document. Almost. I will touch in a bit on this. But if I'm using normalization, I have to go out and query additional locations. And that matters because if I'm doing that a lot, that can cause me to have a huge fan out of additional work in order to show what I need. Now, there's still an issue here. The company employer store as references. But why is that? Because if Nancy changed her name, Nancy is not part of the order. The fact that this employee has helped you with this order is important. But the name of the employee, it belongs to the employee itself. So in this case, I have two types of data. One, which stores the point in time, and one that I need the immediate reference. When I'm querying over that, when I'm querying over that, you can see that we represent that as tabular model, but the actual data is JSON. When I query over that, I'm able to see all of the interesting details. But what about this? In the case of RavenDB, you're able to do something like this. Let's say o.lines. And this is very similar to a join, except that you don't have to suffer from Cartesian product. Notice also that the location of this is really important. If I wanted to write a join, I would do it here. Something like this. But this happens very late in the pipeline. And that matters because of the amount of work that the database has to do in order to handle that. Other options that they have are including the additional details. So here I have the details, but notice that I have here just IDs. But I included this additional information in the same round trip to the server. I have the details about the orders on employees, which means that it's very efficient in terms of the network utilization. Now, I have people who tends to go either way. Everything must be normalized and, oh, let's denormalize everything. Don't go there. Try to model based on whatever this is a point in time or immediate reference. Is this value, is the name of the product owned by the order or is it owned by the employee? That's a question to ask. Now, in terms of modeling, we have the notion of associations. The easiest way to handle associations is using embedding. This is what we see here. We embed the lines into the order. So this becomes a whole big object and things become much simpler to work with and deal with. The downside of this is that we don't have to, the downside of this is that, okay, this works here, but how am I going to handle employee orders? Give me all of the all of the orders for an employee. I'm not going to have a list of orders inside the employee. It's the employees, the size of the employee document would explode. I need something else to do here. Here's how I'm going to build. Sorry. Oopsie. So apparently I'm running that in the debugger. Okay. Okay. So here are all of the orders for employee number 1. This is how I'm going to answer employee orders. Now, I'm going to build this guy in my code. Let's go back to how we model the data. There is not going to be an orders collection on the employee. Why is that? What prevents me from having an orders collection on the employee? Well, let's consider. Right now I have 123 items, orders for this employee. What happened if I had this amount? Then touching this thing is going to be like tripping a bomb. Because, okay, I touched this, and now the successful employee needs to load all of the relevant orders. And what am I going to do with million orders? Probably nothing. I probably want to actually show you the count. I want to show you this value. I don't need to expose this. This is a pitfall waiting for you to happen. So when we model our data in our client code, this would be a list, but one to many and many to one would be modeled differently. And we can actually see this here very nicely. Here's the order, and the order has a reference to employee and company. Notice that we explicitly store just the ID reference. In the same sense that we don't have employee.orders, I don't have an orders.employee that has the employee object here. I want to create good separation between the different pieces in my model. Why is that? Let's go back here and consider. What's the problem here? That's not a good idea. In order to support that, it means that I have to somehow load the related employee. And this is fine, but try to imagine running this. Now, in order to access each one of them, I would have to run a separate query. This is called select n plus one. This is really, really, really common in relational databases. Probably the number one reason for many issues with the system. Because you aren't paying attention and suddenly you're hammering the database with a lot of queries. So when we design OpenDB, we design it explicitly, so this is not something that you can do. You could do that, and that's why we actually had the features with the include. So you wouldn't have to go to the server on each and every time. But the model that you set is intentionally isolated. Company has no orders collection. Orders has string references and not entity references. And employee has no references to orders. That matters quite a lot. Now, what about one-to-one associations? One-to-one associations tend to be really, really rare. They tend to be something that you only need to deal if, I have two pieces in my model that are the same, but should be treated differently. For example, I have a user and employee. A user document and an employee document, both of them refer to the same entity, but they are dealt with, one is dealt by HR, one is dealt by the IT department. That's the only case that you need that. The typical way to handle that would be to utilize naming conventions. So you have user/1, And in the other side, you'd have user/1/HR or something like that. That way, it gives you very nice hierarchical model, and it spares you the need of dealing with more complex details. The last thing that we need to deal with is the notion of many-to-many. And the classic many-to-many is the case of users and groups. So this is the typical way I would handle that. In a many-to-many association, in almost all cases, it's very clear that there is one side that is going to be smaller than the other. In the users and groups, a group is the number of groups you have in your system is going to be bounded to dozens, a few hundreds at most. But if you have millions of users, then each group may contain many, many users. So we store the many-to-many association on the smaller side of the association, this case here. Another good example here is territories. This is stored here because you may have many employees per territories. But typically an employee would have a highly bounded set of territories it belongs to. Okay. Questions? You can use the slider, or if you're on Slack, on a Zoom, you can send the question on the chat, and I will handle that. Okay, we have, is it possible to see different values in times for a collection by change vector property? So I think that you're talking about this, and the answer is yes. If you set things up properly, you can go back in time and see the difference as things change. For example, I'm going to change it here. And now I can go back and see, not this one, this one. Okay, here is the current and here is the old version of the data. This allows us to basically have a view of the changes in the data. It also allows us to look at older versions as they change. And the idea here, this is referenced indeed by the change vector. The Slido code is NoSQL. I'm writing that again in the chat as well. And okay, I'm waiting for more questions from you. And so this is revisions, and this is indeed allows you to store, to look at the different values. The idea of revisions is that in many cases you want to have an audit log. So you can basically just define it here. And let's do something easy. Let's define things for employees. And now I can go here and say that, okay, I changed the first name on Laura. Here things are. I actually do things more interesting using revisions. And let's make a change to the data. What I'm basically doing, I'm changing the structure of the documents so I have a name instead of first name and last name. Now, you will notice that I made a mistake here. You see that I have a typo? Let's see what happened. I now wrote basically garbage here. But because I have revisions, I can go back. In fact, I can do it globally. And let's say, oh, you know what? I want to go 1 minute back in time. And by doing that, I'm back in good graces. Now, we have more questions now in Slido. Okay, we have a question. Can you add files as attachment? In this case, yes. I wanted to focus the actual presentation on modeling concerns in non-relational world. If you want me, I can go over and talk about some of the features. Look here, we have attachments. In this case, I have the employee ID, the employee picture, sorry. She's very happy. And the whole idea is that, yeah, you can just go in, add some binary data that you care about, and it's here. This is very, very similar to how you would model data on top or attachments in emails. You have the text of the email and you have attachments that are sitting on the side. There are other things that you can also do. For example, you can define what is that? You can define counters. And the idea with counters is that instead of having a property in the model that you have to update, but you have to update the whole document, you have something that on the side that you can update concurrently in a distributed environment. The idea here is that you're able to do that when you have something that changes rapidly. Likes on an employee, it's very likely that you have two users who will press like on the employee at the same time when you don't want them to wait for one another. There is also the notion of time series, which allow you to track changes over time. And that gives you basically the ability to track things, and it's very efficient, storing large data and a bunch of stuff like that. We have a question from Vitali on whatever we can query revision. And the answer is sort of. In general, revisions are meant to be just the audit log. You can use a subscription to query that. And the idea is something like that. Now you can see that I'm getting, instead of the document itself, I'm getting current and previous. And here is Laura. This is the new one. And the old one was Laura versus Laura 2. I can now query things like this. Current first name. And that gives us interesting details. For example, here, I don't have a first name because I have the name here. So that pops up. So that allows me to query on the data. I can also store that, and now I have a subscription that I can subscribe to, and the database will tell me, oh, whenever there is a change that matches my query, that's how it's going to look like. Okay, Adrian is asking, are there any open standard effort on standardizing the query language used by document database? I would like to avoid being too tight on a specific vendor. That's a good question. In the case of RavenDB, we use something called RQL, RavenDB Query Language, and that is intentionally meant to be very similar to SQL. The whole idea is that you're going to be it's going to feel very natural for you to query on that. Mongo, for example, uses something like JSON AST, which is very different. I can tell you that in general, trying to move between vendors on non-relational platforms is probably not going to be very easy. Even between relational database, which have roughly similar feature set, the ability to move between databases tends to be very rare, not something that you generally do. Can you give us some pros and cons about using RavenDB instead of Mongo? I can. RavenDB is transactional. It's much easier to set up. You get this kind of user interface instead of this. The API that you generally work with something like this. 1 second. Here you go. So you work with story type objects. You modify them. You get automatic change tracking. You get automatic unit of work, whole bunch of stuff like that. You get support for querying using link and all of the usual. Basically, RavenDB does a lot more work in order to make your job easier. There are also all sorts of features that are quite important. For example, let's look at here. I'm modifying 3 documents and then cognitive changes. In the case of RavenDB, there's going to be one query to the database. There is one round trip to the database. There's going to be one transaction for all of them. In the case of Mongo, you're going to have to make many trips to the database, and you have to have a distributed transaction at best, or in most cases, you would have no transaction and expose the risk of non-atomic operations. Okay. So Francis is asking an interesting question. How do you handle many-to-many relationship where either of the two sides' name can change? For example, your user group example, if the group name changes. Well, I didn't do a good example, a good job here, but the idea is that here you're not storing the names. You're going to store something like this. You're going to store the ID of the group, or alternatively, you might want to store something like this. Again, the whole thing depends on what sort of scenario are you going to run. If you need to access the names of the groups, which I think this is something that you would never really have to do. You do it here, and then you have to consider whatever this name belongs to the user. This is the group. This is the group at the time it was attached to, or if it belongs to the group. I would say that this tend to be the name tends to belong to the group. I want it to look like this, and name change in this case just happened. Okay. Can you have trigger or stop procedure to process the data? No and yes. Again, the typical way to handle that is using a subscription. This allows you to write code that would react to things that happen in the system externally. And the reason for that is that one of the key issues with triggers is that they run as part of the same transaction. And if they run as part of the same transaction, it means that if you need to do something external, then and it fails, that's pretty horrible thing to do. For example, let's say that I want to ping a webhook whenever a particular user's document change in a certain way. For example, let's say that my logic is something like from orders where greater than whatever. In this case, I need to go and tell the IRS about that. If I'm doing that inside a trigger and the remote server that I'm talking to is down, I have an issue. I can either reject the transaction, I can either reject the transactions and fail. I should not have run this in the debugger. I'm not sure why I did that. I didn't think that I was doing that. Like this. So here are the big orders. And the whole idea here is that now instead of doing that in a transaction, either not notifying the IRS or failing the transaction, I can do that behind the scenes. I can do it in a background manner. The other thing that I'm able to do here is I'm able to use indexes, which I have the ability to write some complex ones in order to respond to how the data is working. And that way it allows me to do some interesting way with some interesting with the data. For example, in this case, I'm doing aggregation, but I can also do some filtering in order to say, oh, here are the data that I have not reported on that needs to be reported and things of this nature. Okay, so we have a question from Rick. Can I use that in Azure? And as a service, and yes, you go here, you register. There is even a free tier that you can use, available on all of the major providers, and you run with it. Vitali, Does DrivenDB support schema validation? No, and that's intentional. Let me show you exactly why not. Here we are going to store company 5A. And if we open that in the studio, by the way, there is a live instance of Remini that you can use here. Here is Oren Eini. Run it, any changes? That's nice. Now, does it have to make sense? Now I'm going to do something interesting. I'm going to modify this. And we don't have schema validation because of multi-versioning concerns. This piece of code has no idea about these two fields. Or for that matter, let's make the modification. There we go. And I made a modification. Here is the VIP and here are the additional values. So the whole idea is that in a cross-version environment, I can run things very easily. Now, to be fair, DrivenDB has a client API that gives the ability to do the validation yourself. However, in most cases, you tend not to do that because you already have a good way of doing that. And this is this thing. Here is your model. And you tend to work with strongly typed things, so you don't really have to worry about such issues. In most cases, I would also say that because you're not generally querying using raw strings, you generally query using a strongly typed API as well, I don't think that this is something that is required. And I think that we're about out of time, and I think we run out of questions. Oh, we have a last one. Hi, how it performs on regression queries based on time on large sets of data? Okay, let's say that from orders, count and this. So this is not that interesting. Let's search for, there we go. So notice that right now, this is actually running under the debugger. So ignore all of the performance that you see here. But let's see how this actually works. We right now have 1,000 documents in the database. It's not really enough. What I'm doing right now, I'm actually generating 100 orders that would give us some more information. Again, I did bad here when I run it under the debugger. You can already see how it goes. It's running. And the reason I wanted that is that now we can see much more interesting results. Now, notice that as the size of the data is growing, the speed of the queries remain roughly constant. And this is because of this behavior. Here is this particular order. And now you can see that this is actually MapReduce index on the date and the company that we have here. And this means that we aggregate all of the information here and get it to 101 here. So when we query, we actually query this. If we had enough information, and I don't think that we are going to get enough here. No. Let's try doing aggregation just on the company. That would give us some better results. Now, the first time that I'm going to do that, this is going to take some amount of time. Second time, it's going to be effectively instantaneous. Again, I'm under the debugger. And the reason for that is, here we go. The reason for that is that now I have two examples. One is for companies 85. Just as before, I have 505 entries here. All of them are shared, and this is the total value. Here, I have too many of them. I have over 1,000. So I split it into a tree. Now, orders 20 goes here. And this is the summary for order 20. Now, this is summary for this as well as this. When I add a new value into the system, that means that I'm going to have I'm going to edit here, update this value, and then I'm done. So aggregation operations are going to be really, really fast, even on ridiculously sized data sets. Talking about hundreds of millions or billions of data, because we already done all of the work and the aggregation is incremental. And I have a final question from Francis. Does revenue handle sparse data well? Documents with thousands of properties, but only a few of them are actually populated? And the answer is yes. It does quite well on those. The whole idea is that we don't store any information about properties that are not there. From the point of view of your model, you have to make sure that when you serialize the data, you're skipping data that is set to null. Otherwise, you're just going to have a lot of fields that are set to null, and that's not missing. That's just a value that is set to null. At any rate, if you have any additional questions, because we really are out of time, feel free to ping me at oren@revenib.net. And thank you very much for having me here.
Thank you, Oren. It was a pleasure. Yeah, we hope to do this again soon. Yorina. Okay, the live stream will be available on YouTube, and yeah, I think that's about it. Thank you again, and have a great night.
Goodbye.
Bye.